reflection of light through the mirror and how does the images form here observed. Now let us see the surfaces difference when the object is kept at the plane mirror and the spherical mirrors. So as you all know that in your home you are using the plane mirror. In front of the plane mirror, at what distance an object is kept, the same distance behind the mirror only, it forms the virtual image. So for that reason, you look as the same size as the original. Where the spherical mirror cycle, spherical is nothing but in the form of a circle. But when you are observed the concave and the convex mirror, you are seeing that a part, that is a curved part I told as in the concave mirror. So if you are extended the remaining part to complete as a spherical mirror, you will find the center. That is, a center of a circle is nothing but a center. So from the center point to the edge of a curved part, we will call it as the radius. That is nothing but the line which joins center to the circumference is called radius, as you learn. Now the line which is focusing in the concave mirror to reflect back, that is called the P. Whereas denoted in the P, the same axis which you are joining to focus on that is the axis we call, hence principal axis. So we denoted the distance between the circumference of a curved part to the center is in a radius, whereas the edges we call it as M and N. So in the concave mirror, to find out the radius, we measure from a curved path to the center of the mirror. Whereas to find out the focal length, then before knowing the focal length, let you know about what is meant by object distance, what is meant by the image distance. When the object is kept in front of the mirror, we call it the distance between object to the mirror is object distance, denoted by U generally means. Whereas the image which is formed behind the mirror, that is called image distance, denoted by V. To calculate the focal length, at what distance in between the object distance and the image distance in the spherical mirror or in the plane mirror, whatever the surface will be there, we call it as focal length. So that focal length is always summarized by the object distance ratio and the image distance ratio. Whereas in the convex lens, the same thing, whereas the virtual images which forms behind the mirror. Hence, it is also denoted by P, that is the focus of the object where the reflection takes place, and the line which enters the diameter from one edge to another edge, center to the P will call it as the same radius. Then half of the radius is always the focal length. Okay? Then I hope you have got an idea. The focal length is depending upon half of the radius. So if the radius is 4 cm, then the focal length will be 2 cm. So whereas in the convex also, if the focal length is 2 cm, then radius must be correct, 4 cm only. So which divides equally. Then we wanted to know that always we are saying that the mirrors, few are formed as the virtual image, others are forming as the real image. Let us know what is the difference between real image and virtual image. See, real image means always it is inverted. It means how? If the object is kept upright, it looks as downward. Hence we say that always inverted. Where you are observed in the concave mirror, you are observed. But whereas in the convex mirror, we can see always erect. Erect means as in the same direction of the object. Whereas the second difference what you are observed, whatever the size you are kept in front of the real image to identify, be done while taking the virtual image. So generally these two images you are observed through the concave mirror and the convex mirror. Now you got an idea? Concave mirror forms always inverted, same or diminished in size, and it can be captured on the screen. Whereas virtual image using the convex mirror, it always erect, that is upright, and always enlarged in the size, and it can be caught on the screen. Hence we are using in the side view mirror. Whereas the concave mirrors are majorly used in the dentist because they wanted to see the complete and the diminished size. Because diminished size is always easily they can identify where the decay. Even the solar furnace also majorly the focus point is interior. Whereas if you are observed through the radius, so you find that focal length is always having half of the radius. Then the relationship between object distance, image distance and focal length is how, see, the ratio between the image distance and the object distance always gives the focal length. So for the result, 1 by V plus 1 by U is equal to 1 by M. This is the called mirror formula. So this mirror formula where we are going to use either if they are given object distance, focal length, then you should find the image distance. If it is given image distance and focal length, then we can find out the object distance. So by this you can calculate at different distances when the object is kept in the optical instruments. Then you can calculate the focal length. Generally you observe that whenever the mirror is taken, then they will give focal length how much is there and the image distance how much you will get it. Then easily you can calculate depending upon the focal length. So for that reason, one is the focal length can be calculated by help of radius. Second is mirror formula can be calculated by using 1 by V plus 1 by U is equal to 1 by M. Whereas one more is that you will get it out. So how do you calculate if they enlarge in size? How much enlarged or how much diminished? Then we are going to calculate by the help of a magnification. This magnification, what does it indicate? See, the object size is if 3 centimeter is there. If it is magnified by using the either microscope, when the visible things are very minute in size, then we are using by the magnification formula. That magnification formula majorly depends upon size of the image with the size of the object. So I hope you are all observed in the biology lab to see the microorganisms through the microscope. Then they give on the eyepiece as a 10x, 20x. So that indicates how many times image has been increased. Hence, magnification gives the ratio between the size of an image with the size of an object. Then easily you can find out how many times it has been increased in its size to see with the naked eye. Then it is also can be equated with as an the negative sign of the object distance and the image distance. Why we have taken the negative means always you are all knowing that in the spherical generally it forms the images are always behind the mirror. Hence we are using the ratio between minus image distance with the object distance we are going to calculate. So and one more thing is how remember that radius of the mirror is measured in centimeter. Focal length is also measured in centimeter and the ratio between object distance and the image distance is also measured in the centimeter. Whereas magnification depending upon the size of the object, comparison image and object, then we can say that it is in how many centimeters are there. I hope you understood the 3 formula and in next period you will understand about how does the calculation of a focal length or radius, how do you use mirror formula with the concave mirror and the convex mirror, and how do you identify the magnified object comparison with the image and the object size, or the object distance. I hope you understood. Now go through the text also in detail.